So we have a picture and a graph. Do our Oizerga analysis. So when we look at this x-axis, 025, 020, 015, 010, and then what we can see then is 0005 is here and 0.0000 is there. Vertically, we're at the origin. So on the coordinate plane, we're actually looking like this in quadrant 1. So we know we're situated relative to the origin. The y-axis force in normal units, x-axis time in normal units. So therefore, anything about force and time we'll just read off the graph. The gradient, delta F over delta T, which is the rate of change in force. And the area is F delta T, which by definition is the impulse. And we also know delta P is M delta V. And because the impulse brings about a change in momentum, that impulse is mathematically equal to, in value, to the delta P. We see in this graph, looking at what's going on, we see the force starting out at 0, increasing to a maximum value of 8,000 and decreasing to 0 again over a period of, over this period here, delta T. So now we have an object of mass 2 kilograms, that's this up here in the diagram, collides with this one. This V0 is 0. The graph of the force exerts is shown. Object of the 1 kilogram object exerts on the 2 kilogram object. So the force is in that direction, in the positive direction as specified in the coordinate axes up here. After the collision, the 2 kilogram has a speed of 2 meters per second, and the 1 kilogram has a speed of 8 meters per second. So afterward, the 2 kilogram is 8 meters per second, either to the right or to the left. And the 1 kilogram, I did that incorrectly. It's not, the 2 doesn't have a 1. 2 kilogram has a 2 meters per second, so it's either 2 meters per second this way or 2 meters per second that way. And this one is 8 meters per second, either to the right or to the left. We must determine the initial speed of the 2 kilogram object. So which one of the following options shows the correct substitutions into the equation? So that the initial speed of the unknown. So first of all, which one of these are correct substitutions? So delta P equals F delta T. So it's going to be the average force. So that's going to be 8,000 divided by 2. That's what we're looking for. And looking at the first one, we see this multiplied by the time. So that's F delta T, but this is the F max. It's not the average force. So this one is out. And then if you look, we have 1/2 8,000 times the time interval, and that looks correct. Again, we have the full force, the F max. So that one's out. And in this one, we have 1/2 the maximum force. So now, next, we have to distinguish the other side of the equation. So this is 2 times 2 minus V0. So this is M, and this is the final minus the initial. Now, we don't know what direction the final is, so setting it as +2 is an assumption. And if we look at the first one, we've got a difference in mass. This is delta M. So this is the difference in masses, which that's not something we would do because we're looking for the change in momentum of the 2 kilograms. So that delta P is M delta V, not delta M delta V. And of course, the mass of the 2 kilogram doesn't change from 2 kilograms to 1 kilogram. So this is nonsensical. And so this one can work, provided it's correct, that the velocity is a positive 2 afterward. But the others are all clearly incorrect.